I'm going to quickly go through the classwork we did and the last 2 questions that were. All right. Hi, guys. I'm going to quickly go through the classwork we did on Thursday for those of you who missed it, and then go over the homework. So here it tells us our given is BC is congruent to AD and AB is congruent to CD. These are already marked here. The only other additional information I can make, we have a shared side in the middle. So in this case, we're looking to prove that we have 3 sides paired up, side, side, and side. So we need to add on that statement. So I'm going to go here and say, well, we just claimed that AC was equal to AC. And that's going to be our new claim. Again, whatever you annotate, you have to claim. This is called the reflexive property. Once we have that, you'll notice that everything is marked on the system with sides. So we're going to say, oh, we want to prove this. ABC, CDA. And we saw there's 3 sides. Now, if you try to make this claim, but don't include the reflexive property, it would have told you you don't have enough information. So whatever you annotate, you have to make a claim about. Ta-da! And notice again, there's a help video. There's also examples you can look at with the show example button. So for the second one, which again we did in class, I'm going to annotate what we know quickly. If I bisect BD, I'm cutting this in half. If BC and AD are parallel to each other, we make that Z shape of alternate interior angles. And we're looking at BEC, bacon, egg, cheese. So we need to have vertical angles here. I'm going to make those 3 just to really show. It's messy. So again, whatever you annotate, we make a claim about. So we said that BE was congruent to ED. Why? Because it told us it bisects a segment. We said that triangle BEC, the center one, was congruent to AED, this other center one, because vertical angles are congruent. Oops, and look at that. I meant to write BEC, wrote BED, and look, it tells me what was wrong. I named my angle incorrectly. Again, if we got the error, a lot of people texted me saying, not enough information, you need to make claims before the end. We still need to make a claim about these corner angles. BCE and CAD. C and A would be the vertex, those angles that we marked. And those are alternate interior angles because those parallel lines. Finally, let me clean this up. It's marked for us. We have an angle, and then a side. So our proof statement is already given for us. BEC and DEA. Why? Because angle, and then a side match up. And again, I'm going to mark those real quick. We have an angle, then a side. An angle, then a side. That's the pattern we see. Try. And again, I literally did the same exact mistake. BEC, not BED. I'm literally just typing in the wrong letter. But notice it tells you if you type in the wrong letter. I'm just going to show the actual process because we already did this in class, and then I'll write on the last 2. So for this one, you first are given that AC bisects each other. You over here given first. So because of the given bisects, it creates 2 equal parts. So we saw AE is congruent to EC. We also know because it bisects the other direction, that also is cut in half. Now think what comes next. There's something else we can mark here we haven't yet. And yes, that would be vertical angles. So notice this gives us a side, an angle, and a side, which would be our last line of our proof. So feel free to screenshot this or write it into your own system. Again, bisect, vertical, side angle, side. Going to number 4. It tells us we have a parallel line and congruent segments. So we're thinking we need to find out about these 2 triangles. Anytime I see a vertical line, parallel lines, I'm thinking alternate interior angles. Anytime I see this X shape, I'm also thinking vertical angles. So in this case, we can say angle B and angle D, aka ABE and EDC, are congruent because they're ultra-interior angles. They make that Z shape. We can also claim, again, as always, vertical angles are congruent. This gives us an angle, and a side. And that's going to be our answer here. So notice, we're always trying to figure out what makes it congruent by finding one of these patterns. We have to fill in the information first. For number 5, hopefully it's jumping right at you what you need to do. There's only a 3-step proof. Once you see that little bow tie shape, the X in the middle, you're thinking vertical angles, EDA and FDC. Notice we need to use all 3 letters because angle D has multiple angles at it. Once we do that, do you know the pattern? Well, we have an angle, a side in the middle, and an angle. And that's going to be ours right there. Angle, side, angle. And for number 6, do the same thing, and then we'll work on number 7 and 8 together. So here we have a lot of given information. So the only thing we need to add on is to figure out ABD and CBD are. Now, if you were tempted to do this, we saw in class that that leads to angle side side, which we don't want. So instead, let's use the given information. Oh, wait a minute. Check this out. It tells us that BD bisects ABC. When we bisect an angle, we cut it in half. So that angle up top is cut into 2 congruent parts. And now we have an angle, a side, and an angle. Again, we're getting that pattern because we literally have an angle pair. We have a side matched up from the given, and we just showed this angle was cut into 2 congruent parts. So our pattern is angle, side, angle. So for this one, immediately when you see it parallel lines, I want you to start thinking, wait a minute, we looked for ultra-interior angles. There's another angle pair you should think of. I'll give you a second to think. Yes, you should think vertical angles. And then if you bisect the line, you're cutting that in half. So it does not matter in what order you do these 3 steps. So if you wanted to put parallel lines first and vertical angles next, that's fine as well. These 3 are like your body paragraphs. They're interchangeable. But notice, segment bisector is based on the given. Vertical angles is based on the diagram. Parallel lines form ultra-interior angles is going to happen when you have parallel lines cut by a transversal every single time. This gives us angle, side, angle. Again, if you put the middle part in different order, that's fine. Your given comes first and your proof line comes last. Finally, I see the word bisect, cut in half, and it also is marked an angle for us. Now notice here, it's important to think what we're actually trying to prove. We're trying to prove BEC and DEA are congruent. It's very similar to one we saw before. So in this case, our body paragraphs look like this. A segment bisector cuts into 2 different parts. We get that from the given here. So again, based on this, we make a claim. And we also have vertical angles, which are always going to be present when you have lines intersecting in an X fashion. At this point, that does give us an angle, a side, and an angle. An angle, a side, and an angle, which will complete our proof. So again, most of the students I talked to had trouble with this weren't actually filling in this middle part. They were annotating our diagram and going right to the triangle part. You need to actually make claims based on what you annotate. The big ones are vertical angles, bisected segments and angles, shared sides, and ultra-interior angles. That's all, folks.